Our next panel is our Statistics in the Crime Lab panel, and we're going to be hearing, this is really, we've been hearing about judges, we've been hearing about statistics, now we're going to hear about the life and work of crime labs. And so we will hear first from our own Linda Jackson, the director of our Virginia lab, the Department of Forensic Services, where she has been since 1995, beginning in controlled substances. She teaches at VCU, so she's also intimately concerned with how do you educate future scientists, not just within her lab, but people going into forensic science. She served on the National Commission for Forensic Science that Jed Rakoff was just speaking about in his remarks during lunch. We will next hear from Peter Stout, who's the CEO and co-president of the Houston Forensic Science Center. And it's the crime lab in Houston. He was a scientist at RTI before then and had done work in toxicology. He's the president of the Society of Toxicology, also in the U.S. Navy Medical Services. And so he'll talk about some of the innovative work being done at the Houston lab. We will then hear from our own Sharon Kelley, who's both a JD and a PhD. So addressing some of the concerns about lawyers, doing nothing but physics for poets. So Sharon works here at the Institute for Law, Psychiatry, and Public Policy and is a collaborator on a whole host of different projects that we're working on within UVA as part of CSAFE. She's going to talk, though, about her work looking at data at the HFSC, the Houston Crime Lab. And then we will also hear, I guess, last but absolutely not least, from Henry Swofford, who's the chief of the latent print branch at the Defense Forensic Science Center. So that's the crime lab that does work in military criminal cases. He's been there since 2008, and he's began in the latent print unit. He's now the chief of the latent print unit. And so he'll talk about some of the innovative work that he's doing at the Defense Laboratory, and some of which has also involved collaboration with CSAFE researchers in statistics. So I couldn't be more thrilled to hear this panel. I will again be, like our other moderators, I'll be sitting off to the side. I have some questions, but I hope you all ask questions when the presentations are complete, since we really want to have more time, hopefully this afternoon, for lots of lively discussion and interactive exchange. We'll start now with Linda Jackson.
All right, good afternoon. Thank you to Brandon and CSAFE and NIST for having us here today to do this. As the first speaker of this panel, I was kind of asked to give an overview of forensic laboratories in general, and then also kind of how we approach research, statistics, and outreach in forensic laboratories, because those are sometimes not really our main mission. And so these are our 4 laboratories. So in Virginia, we have 4 laboratories. We have the Central Lab in Richmond, and we have one in Roanoke, and one in Manassas, and one in Norfolk. We try and do it so that folks who go and support the analysis from different jurisdictions don't have to drive more than 3 hours to support their analysis with testimony, except for that little part of Virginia that just keeps on going. And that is 6 hours from Roanoke, so it doesn't fit that rule. But we are a large state system in Virginia. If you want analysis in forensic biology or DNA and drug chemistry, that type of thing, you have to send your evidence to us for criminal investigations. So there are not local labs that do that type of analysis. We were created via legislation as an independent agency back in 1972, and that is definitely against the norm as to how laboratories were being put together at that time and for many years afterwards, where the normal model was to either put the laboratory within a police agency or within an AG's office or some kind of prosecution. But we were in just one of the regular old state agencies. We were elevated to department level, which means I am actually appointed as the director and report to the Secretary of Public Safety and Homeland Security in the governor's cabinet. And when we were elevated to department, we were given oversight with 2 different bodies. We have a scientific advisory committee, which is made up of scientists from across the country that are appointed by the governor to help give us input on our scientific processes, as well as a policy board, which is our forensic science board, which is made up basically of stakeholders in Virginia from the different kind of areas of the criminal justice. We've been accredited since 1989, first with ASCLD Lab, the legacy program, now with the international program, which holds us to international standards. 17025 is the main international standard, which is the one for testing and calibration labs, not just forensic labs, but any, a water lab or any kind of testing laboratory or calibration lab could be held to those standards. We're actually scheduled to be reassessed for our overall accreditation in May of this year, and that will be with ANAB, who is now an accrediting body. They've merged with ASCLD Lab. And so Virginia's had a couple of firsts. We're a little bit of a pioneer in a couple of areas. So in 1989, we were the first laboratory system that started using DNA on criminal evidence. And with legislation that the General Assembly did in that year, we were the first state to create a DNA databank of convicted offender samples. And in 2009, we actually were, I think, the first, if not definitely one of the first, laboratory systems to put all of our manuals, our procedures manuals, our training manuals, our quality manual on the internet. So for those attorneys that are interested in how we do certain analysis, or if anyone from the scientific arena wants to see how we're doing our testing, they are welcome to look at those online. And we certainly have gotten comments through the years of, hey, why do you do this? And it's a great way to learn, and to have those out there. So our agency mission statement, generally, our mission statement is that we're to do the analysis of evidence in criminal matters. We receive evidence from over 400 law enforcement agencies across Virginia. So with that many different jurisdictions, we do not have any of our scientists go to crime scenes. We do all of our work in the laboratory. So in that regard, we are absolutely not like any television show that is on today. But in our mission, it does say that we are to advance the understanding of forensic science. And in my mind, that means both research to advance our understanding of the science, as well as outreach to our users, where we're advancing their understanding of the science. So in our Richmond lab, which is our, where our administrative headquarters are, we do have a division of technical services. And in that, we have our quality manager who oversees our quality system. That's all of our quality assurance, proficiency testing, and that type of thing, and our safety management. And we have program areas where we group together our disciplines and have a technical program manager who is over each one of those. And so it's a little bit like the OSEC scientific area committees, where we try and take advantage of the commonalities between different disciplines and increase the consistency between different disciplines by having that one point of technical management. And so these program managers are, they're in charge of coordinating any research efforts that are in their program area. And so they are, they make sure that everybody's working on approved projects and that they are working on projects that are designed in a way that will actually mean something when we're done. And so many of our projects revolve around method development and method validation. And so also we do things that are evaluating methods that have already been developed, like the developmental validation has been done by maybe a manufacturer of a DNA kit. And so then we're doing the application validation in the laboratory. So generally we're looking for research that provides a new method that either has increased sensitivity, increased selectivity, or increased efficiency. And so we do have two research staff. We have Dr. Susan Greenspoon, who's our forensic microbiologist that leads all of our DNA research, and Dr. Becky Wagner, who leads our toxicology research. And they have been very busy of late, and they have staffs that have been supplemented by various grant projects that we have where we've been able to hire people off of grants. So just to give you an idea, we get about 60,000 cases submitted every year. We do have some significant backlogs in some of our sections. At DFS, anything that is in our caseload is considered a backlog. It doesn't have to be there any particular time period before we consider it a backlog, because if it's been submitted, we consider it in our backlog. And this is the number of staff members that we have statewide for each of the sections, and the ones that are in parentheses are people who are qualified. So the difference is obviously the number of positions that are either in training or in the hiring process. And generally, these training programs that scientists go through are between 10 and 12 months long before they are able to independently work on casework. And they can be longer. In firearms, it's 12 months. And so, in general, when we have changes to our workload, we are a support agency where we are having to react to changes in cases that are submitted. So, we've had a large increase in drug submissions because of the opioid crisis. We've had a large increase in PERC submissions, which is what we call sexual assault kits in Virginia, because there's been legislation saying that they will all be submitted to the laboratory, which obviously has increased the number that come in. And so in order to get additional staff, we have to establish what a new trend is and be able to then talk to the Department of Planning and Budget and so forth to be able to articulate the need for additional staff. And so it's always a balancing act as to whether you're going to put your resources towards working on what is coming in the door or working on a new method that will make it easier to do what's coming in the door. And so it is where you want to make sure that you are focusing on the most helpful projects. So currently in forensic biology, we've been doing a lot of research in forensic biology. Like all laboratories across the country, we have implemented new multiplex DNA kits, which look at 24 areas of DNA instead of 16 areas of DNA. And so not only did we have to validate the kits themselves and the analytical methods with the kits, we also had to validate the probabilistic modeling that we do for our statistical reporting that goes with the results that we get. We're currently looking at a different probabilistic modeling kit, the STR mix. We currently use TrueAllele, and so that we have that project ongoing. And with the large increase of the amount of sexual assault kits that are now coming in the door, we've replaced our microscopic sperm searching, where you kind of look. You look on the slide, and then you look on the slide for the sperm, and it takes a long time to do that. We have now moved to male DNA screening, where you take a little bit of the sample and you do a quantitation, and you look for the amount of total DNA present and the amount of male DNA present. And anything that has male DNA present, you just go ahead and send that to traditional DNA testing. I have a couple people nodding. That's great. So one of our big projects that we have a person that's working on this through the NIJ SACI grant is to evaluate some new DNA quantitation chemistries and new quantitation instrumentation to be able to have those ratios that we see for the male DNA to the total DNA, have those really to where we have a large amount of confidence in those ratios so that we can make method policy decisions as to how to move forward. So if there's no DNA, or male DNA, we want to feel confident that we can say, let's stop. If there is a lot of male DNA, we feel confident that we're going to get a good profile. Let's go to fusion, which is the 24 loci. If we feel like there's a very small amount of male DNA but a lot of other DNA, let's go to YSDR, where it would only look at the male DNA. But we want to statistically validate that so that we can make a good decision as to how to move forward. In toxicology, with all of the different opioids that have come out recently, and they continue to come out with the derivatives of fentanyl, we have a new qualitative method, and we have a person on a CDC grant who's going to work on making that a quantitative method for fentanyl analogs, which is a lot more labor intensive than having the qualitative method when we're just saying we can see it versus we can see it and this is how much is there. So for projects that are not in those two areas where we have a research scientist, it is a little more difficult to put the resources forward. So we did apply for and receive an NIJ grant in their research series to evaluate a latent sleuth software. And the purpose of the latent sleuth software is to evaluate to see if it would increase the accuracy and efficiency in cases that have a large number of comparisons. When you have maybe one unknown latent and you have 10 suspects, most likely those 10 people have 10 fingers, which makes it so that you have 100 comparisons that you have to do against that one print. And so we wanted to validate this software that allows you to scan in all of those prints, and it works like a little mini database to help you prioritize which prints to do the side-by-side comparisons on. And so in order to do that, we actually took advantage of the fact that Dr. Kafadar is close to us, and we contacted her, and she was very helpful in helping us determine how we should group the prints and evaluate the different levels of quality of the prints first, and how many replicates we should do in each one to be able to say what about it at the end. And so it's been very helpful to have contacts, and I think that the CSAFE people have been fairly, I guess, I don't know what the right word is, but you've been helpful in putting yourselves out there as resources, and so that has certainly helped. And so right now, this project is in phase 2, where we are able to evaluate it on casework, and so so far it has been very promising. So along with our relationship with Dr. Kafadar, we have a long-standing relationship with the Virginia Commonwealth University. Since they started their program, they had a forensic science concentration in their criminal justice degree that started back in 1984. And so we've had a lot of scientists that have taught classes. I taught a drug analysis class for many years, and I'm actually teaching a professional practice class now, which is exciting to kind of mentor these students. But it also has allowed us to have collaborative research projects with faculty that are doing less straight up method validation kinds of projects and more basic research kinds of projects. And it's given us the opportunity to have access to journals and different types of papers and so forth. That's one of the things that a lot of forensic laboratory staff don't have access to because they don't have a relationship with a college library where they would have that kind of access. So we do have a new relationship with George Mason as well. That's new. We're teaching a DNA class in our northern laboratory this semester. So obviously, statistics and DNA analysis have been used for years, but as we heard earlier, the population genetics data sets that are available for DNA make it a lot more amenable to that than in physical evidence, where there are not those kinds of data sets available. But one thing that we have been doing to kind of prepare ourselves to be able to bring statistics into physical evidence is that we've had folks from CSAFE. We had Hal Stern come and speak to all of our firearms staff, and we had someone who I've now forgotten her name from UVA come and Allison, yes, came and spoke to our latent print staff, and that has been very helpful. We had some firearms examiners go and look at all the different 3D imaging options for firearms. It is very difficult in deciding where to spend money on some of these expensive 3D imaging instruments for firearms, and it's a little bit, you don't want to be caught in the VHS beta thing where you're not sure which one's really going to be taken. See, some people got that. So, yes. So, yeah, of which one's going to really take off and which one is going to kind of go the way of the dinosaur and not be utilized. So we've gone to Alicia's lab and looked at the Sensifar that they're using, and we've gone to the FBI and looked there. And so we're still trying to figure out what is the best fit so that we can purchase one, because we really only have the funds for one, and they seem to all do different things. Yeah. So we participated in white and black box studies that have been happening. And one thing that's just something, I guess, that was apparent from the panel from the statisticians is I don't think that at this point that there is consensus among statisticians as to what the best way to testify and report some of this information is. And so we're really hopeful that in the near future that will be something that there is a little more direction on, either whether it's through OSAC standards or whether it's through CSAFE, to where we can feel confident in what it is that we should be saying. So, and we have gotten the FR Stat program from Henry's lab and have started looking at that, and definitely need to look at it a little more with that. So training and outreach, we certainly feel like, based on Judge Rakoff, his comments, that it is very important that we're providing training and outreach to the various folks in the criminal justice system. And in the last few years, we have really stepped up our efforts and given talks, whether it be DFS 101, how to get records, what testing do we do, what are our capabilities, what are the strengths and weaknesses, that kind of thing, to law enforcement, to attorneys, and we've had several requests recently for groups of judges, which has been great. And we are trying to start up a program for the training of attorneys and judging, where we're actually training of attorneys and judges, where we're actually not focusing on like what we can do, but really what is the underlying science behind the different disciplines. And we're trying to use a model that was started in Arizona that they have been very successful with, and we're just going to pilot it this year with 4 courses taught about forensic biology. Our goal is to have them in each of our 4 labs so that attorneys from across the Commonwealth would be able to attend. And so right now the plan is for those to be kind of in the September-October timeframe. So obviously with outreach, our most common communication is actually our reports. And so several people have mentioned the NAS report, so I bring that up as well. One of the big limitations that was brought up was the fact that the reports, a lot of times for forensic science, are very, very brief. So the example here is the greenish-brown plant material in item 1 was identified as marijuana. And so back in 2009, that was actually quite common for drug reports and for other types of reports as well. But not only because of that criticism, but also because of changes to accreditation requirements, much of the information that gives the reader information about how to evaluate the analysis that was done, such as what was tested, what the results actually apply to, how it was tested, are now on the reports, which they were not before. So this is actually one of my drug cases from 2005, and I give it as an example because it truly is just like the NAS report said. It said there were 23 plastic bag corners containing off-white solid material. I found cocaine, and it was basically 2 grams of solid material. So you have no idea of how many of those 23 bags I analyzed or whether this result can be applied to all of those or not. I can tell you I did not analyze all 23 of those bags. So, but in 2017, there have been quite a few changes made. So this is a very similar drug report. I tried to find one that was similar. This is 29 plastic bags containing off-white solid material. So now it's very clear that the weight includes the solid material and the innermost packaging. So if it had been a net weight, it would have had uncertainty to that measurement as well, but since it had the bags in it, the uncertainty is in the notes, but it's not on the report because it's not really a very specific weight to how much the solid material itself weighed anyway. It says specifically that the contents of 5 were analyzed separately and each was found to contain cocaine. So that tells you that you cannot infer the analysis to any of the other bags. You only can say something about those 5 because that's all I tested, and that's not a statistically valid sampling scheme. I used color test, TLC, and GC-FID-MS to do my analysis. Supporting examination documentation is maintained in the case file. So that is actually something we started writing on our reports after my many discussions with folks on the commission when I was on the little group that talked about what should be on reports because the defense attorney said it was absolutely not clear, that there are other things that I should ask for. And so we have started putting a sentence on there saying, yes, there is more, you can ask for it, and that the above listed methods are found on the website, and it gives the website address. So just an example, here's a similar example for toxicology. This for the concentration values does have the uncertainty of measurement listed, and down here at the bottom it talks about what level of confidence those uncertainty values are reported to. At DFS we have selected that we report drug concentrations at 95% level of confidence, whereas alcohol is reported at 99.7%. I don't know if you know necessarily, but alcohol is the most litigated thing that we do in forensic science, and so 99.7 seemed prudent. And then lastly, I just wanted to briefly say something about uncertainty of measurement. Other folks are going to talk about error and error rates, and uncertainty of measurement is a little different than error and error rates. For a measurement itself, error is actually the difference between your measured value and the true known value. And for evidence, we generally do not know the true or known value, so what we can do is we can estimate the variability that is always present in measurement processes. So if you had a teaspoon of sugar and you used this measuring device because you did not want to put too much sugar in your coffee every morning because you're on a diet, and so you are going to use this perfect measuring spoon and put sugar in your coffee every morning, you would probably not very often have the same number of sugar granules in your coffee every day, even if you leveled it off and did a very pristine job of measuring, because there's always variability in that type of measurement. And so what uncertainty of measurement really allows you to do is characterize what that variability is and be able to report that so that folks actually understand what the reliability and confidence of that measurement are. And so it's actually should be called confidence and not uncertainty, which sounds like it's not a good thing, but it really is. So anyway, hopefully I can answer questions when our panel is done, and I will pass on to the next person.
All right. All right. So I'm going to talk about blinds. I can drone on all day about all kinds of things that I'm excited about at Houston, so hit me if I get carried away. Houston, just for a little bit of an example, is where Linda's at. We're actually fairly comparable as one laboratory to the DFS state system. We're one laboratory, but about 200 employees, and we get about 30,000 requests a year. So request-wise, about half the size of a state system. Now, the other thing you have to keep in mind about Houston is a very real part of Houston's history is a 2003 New York Times headline, "Is Houston the worst crime laboratory in the country?" That is part of Houston's history, and that's why I'm president and CEO, not a director. A choice was made in 2012 to take the forensic operations out of Houston PD and roll that into a semi-privatized corporation. It's called a local government corporation. So I have an independent, separate board of directors, a citizen board of directors that are non-compensated. They're everything from exonerees to defense attorneys. That's my boss. They can fire my butt if I'm not doing it right. They have fiduciary responsibility for the laboratory. They're who approve my budget. So it's a little bit different mix of what independent looks like. There's a few different versions of it around the country. But when I start talking about blinds, which I think are really cool, I do have to have a little bit of sensitivity to, if you look at the Bureau of Justice Statistics survey of publicly funded crime laboratories, the 411 publicly funded crime laboratories, half of those labs in the country have fewer than 24 employees. So I have a gigantic advantage to being able to do things like this because of my scale. With 200 employees, I have a quality division within the company that's 7 people. And that's what they do, is just quality monitoring. Not every lab's got that when the laboratory director is also the quality director, is also the procurement officer, is also. So while I think I'm a gigantic proponent of blinds, I get it. It's not necessarily a reality for a lot of the laboratories in the country. So, blinds. I started my career in the military, so some of what formed my view of blinds is the military's drug testing system that has run blinds and double blinds through their system for about 30 years. Also, the National Laboratory Certification Program, which oversees federally regulated workplace testing, has done blinds and double blinds for about the same period of time. So that's kind of the framework that I've come to the crime laboratories from. So we're looking to enhance our proficiency testing. So this is an expansion on top of open proficiencies, not in replacement of. And it's really a system test. The design of this is, and the intent is to test the entire system from the point it comes in the door to the point it's reported. Anybody familiar with the Hawthorne Effect? I think most social scientists understand Hawthorne Effect. It basically, in short, is people behave differently when they're watched. This kind of is a giant Hawthorne Effect experiment, and can we use Hawthorne Effect to basically modify the functioning of the system? Can we nudge the system into the system performing more like we would want because we're putting observable materials through the system? All right, so what we do is we basically have 2 branches. One are materials that we either have manufactured for us or that we manufacture to mimic actual casework. They're put into the system before any of the analysts or even some of our client services folks would know that they're samples. And this is managed by the quality division, and they go through the entire system all the way out to the end to report. The other aspect that's largely right now in firearms, but we're looking to get it put into latent prints as well, is a blind re-verification of a percentage of the cases. So these are cases that we select, we blind them to another verifier. They have no idea of the conclusions or that this was previously verified, and then we look at the comparison of the 2 results for concordance. That's got more involvement from the sections because they have to understand at the section management level what cases are being selected, help to de-identify stuff, so they're a little bit more in on that game. So here's the sections that we've got it running in and the basic dates when we started. Toxicology is by far the most mature. That's where we started, like Linda said. Alcohols are the most litigated thing that any forensic laboratory does. Drives me nuts that somebody facing 3 to 30 for something like a drug offense has no defense, and somebody who's looking at a misdemeanor to alcohol has a very effective defense. I'm just saying. We started in alcohols. The most recent one is digital evidence. So we've now got this running in 6 of the sections. I'm pleased. I'm pleased with where we're getting with it. Here's where I could really go all day. I've got all kinds of anecdotes of things that we've seen out of this. You really, in order to stand one of these up, you have to have somebody that is behind it. That, I guess, is me. Kind of works out. I'm the guy in charge, and I get to be behind it. You got to involve the law enforcement agencies. Even we do, because I need the law enforcement agencies basically to submit these things. I've got to integrate it within their case numbering systems. You've got to have them involved in it. And then the one that I also would suggest is that you test the system, not just test the fact that you're testing your analytical system, but you test your actual system itself. But we have seen all kinds of things. Obtaining samples. So we've recently now gotten it worked out where we've got seized drug materials, particularly so we can get hold of large quantities of methamphetamine or pills or cocaine so that we can have a reasonably homogeneous material for repetitive testing. Getting hold of firearms. so that, because firearms examiners start to recognize weapons really quickly, so you kind of got one shot through of a given firearm before they're going to recognize it, so that we got a sufficient supply of firearms. We've got the HFSC, you know, bake sale for firearms. But so we got a supply of those, a supply of the manufacturers of, say, toxicology samples. Actually, RTI is the one that manufactures the toxicology samples for us. But you got to get those worked out. Actually mimicking the casework, and like I say, I could go on this part a lot. Most of the places where blinds have been spotted, it hasn't been because of the scientific nature of it, wrong drug, weird stuff. It's been because of packaging. It's been because, this is the example I use, the handwriting's too neat and there were no spelling errors. Can't be a cop. It's always great for a giggle, but you think about what that is, and I saw on about this one a lot. Yes, there are very real science problems in forensic science that we can't ignore. But most of the problems that labs struggle with day after day, problem after problem, aren't science. They're engineering. They're getting the right sample in the right place, identified the right way, into the right tube, with the right report, going back to the right person 100,000 times a year. It's no trivial feat. And when you think about what's coming into the laboratory, looks something more like that. The crap that comes in the door creates a lot of the problems that go out the back of the door. So now our quality division uses their non-dominant hand and tries to do stuff behind their back so that they can mimic cop right. But it is really subtle stuff that analysts will pick up on. They will see, one of the better ones that I use as an example is, we don't usually see that drug from that part of town. So you think about that. We talk a lot, and I've talked a lot with UTL Drawer about domain relevant and domain irrelevant information. So is location within town domain irrelevant, creating an unnecessary bias because they're now limiting the drugs that they would think could come from that end of town? Or is it actually an error checking mechanism, that they understand what makes sense to come from that area, and if they see something weird, they're going to ask more questions about it? I don't know. But they see stuff like that. They'll see stuff like an officer's employee number doesn't jive with what his badge number is. Those two things can't line up right. They will see an agency case number, because our turnaround times are fairly quick. If an agency case number ages more than about a month, they'll start to see that. They'll see stuff that's not printed on the typical printer that they usually see other cases come through. The printer's too clean. Those are the things that they notice, and those are the things that are giveaways. So our internal logistics of doing that. And then, yeah, the integration with the databases. These are two places. I think we figured out APHIS. We insert 10 print cards into APHIS. We do 5 at a time. And so we've got an APHIS, we get APHIS hits back on latent prints. I'm still working on CODIS. I think I've got a strategy for how we'd integrate to CODIS, but that's a real sensitivity. But we call it the analyst detection incentive. I've got an offhanded bet with the staff that if they find a blind that is a blind, I've got a Starbucks card in it for them. And if they find a blind that's not a blind, they owe me $1. So I've given out about a dozen Starbucks cards, which isn't too bad, and I'm up $2. So one of those, and I love these two stories, one of those was in toxicology, because the name on the case, if you sounded it out phonetically, it came out more tequila. Yeah, on a toxicology case. But no, it was actually a woman by the name of Morticia. So she owed me $1. And then the other one was real early on in the program. We had blinds running in toxicology and firearms, not in any other section. And I had an analyst out of biology come to me and say, I think we have a blind. So again, you think the Hawthorne effect, a lot of this is the fact that people know these things are going through there changes, even when there aren't blinds, it changes how they're approaching stuff. So again, you know, I guess I've got a little latitude, I can do things like this, but I would encourage something like this, because part of what made me think this one is in the military system, you know, they'd run blinds forever. Blinds were kind of obvious in that system because they were made by what, at the time I was still in the military, so what was Armed Forces Institute of Pathology, AFib. I'm not sure who makes them now. But they were packaged kits that went out to commands. Sometimes the commands wouldn't actually read the instructions, and they'd just send the packaged kit straight to the lab. Okay, that's obvious, that's a blind. But they were always very consistent volumes, very consistent colors, and then when you got through screening them, they all had the same concentrations of all 5 drugs. every time. They stuck out like a sore thumb. So everybody kind of laughed up their sleeve of, well, that's a blind. So trying to design and press the system early on so that 5 years from now, people aren't giggling because they always know what the blinds are, is trying to incentivize they're actually finding them. And now my quality division hates this because they go find them. So here's kind of the scale that we've been running out, 2016, 2017, and then what we're targeting for 2018. Some bald-headed lunatic keeps saying, I want to target 5% of the workflow going through there. Where does 5% come from? Number I pulled from the air. National Laboratory Certification Program runs at a 3% requirement for double blinds to laboratories, and military system runs about 3%. I picked 5 because it's something that I think financially we can manage. It's enough that everybody has an expectation they're going to see them. So it's not so small that they never think they're going to see one. It's a little bit like random drug testing. You got to have a high enough percentage that people believe they're going to catch one. But you can see, like controlled substances, that's a big number that we got to try and get to. We've run about 400 through the system in the last 2.5 years. So short of, like I say, the NLCP system and the military system, I've not found any other system that's run that many consistently through. I am really interested. Anybody knows of any efforts around this, please tell me. I'm really interested to know. But most of what I've found in crime labs have been, they've done 2 or 3 cases a year. Tony Tessaloro out of the Toronto lab in Canada has done 2 or 3 cases a year for about the last 10 years. Henry, your group's done like 3 cases, I think? 3 or 4 cases. Institute of Forensic Sciences in Houston does like 2 to 3 cases a year. That's kind of the scale that I see most crime laboratories do. So we're a little different scale on that. All right, so what does that let us do with this? So Cliff Spiegelman is the one that's worked with me the most on this. Bill, you've helped out in some of this. There's a few other people that have helped try and steer me in the right direction. But in the interest of my not blathering on all day, I just stuck with toxicology and just alcohol data. So as an example, here is we have alcohols targeted at 5 different concentrations and complete negatives that we run through as blinds. This is one that's targeted at a 0.02 concentration. So you can see that's over almost 2 years there of the same material. The red lines, this is just Levy Jennings. The red lines are 3 standard deviations, not really the control range that we use, but just so you've got kind of an idea of the variability in it. It's really shockingly reproducible. And you can also see across that 2 years, there's a slight but real decline, which it's alcohol. It evaporates. It's alcohol. The blood, while it's preserved, there's still some metabolic activity going on. You would expect that. For comparison, that same chunk, if we put it onto the same scale as what we run for opens at a different manufacturer of a 0.02, you can see, and this is one of the things that we're starting to see, as our reproducibility gets tighter, I can spot the difference between manufacturers. So those are 2 different manufacturers. The blue area is what RTI manufactures. The upper one is a UTAC control. So we try to gear our controls that we've got at least 2 separate sources of manufacture. For alcohols, I think I've got 4 different sources of manufacture, including our own internal manufacture. But you can statistically differentiate. Those are both targeted at 0.2. But the manufacturing of this doesn't come out at 0.2. So we need our manufacturers to step up their game and get more accurate in what they're producing. Here's a comparison. We started this more recently. Yeah?
Can you say what you mean by open?
Open. So, okay, so an open control, so blind is run, it's inserted in as a sample. The analyst doesn't know it's a control. An open control is set up on a batch. The analyst knows it's a control. It's set up with the batch as an open control. They know it's a control that's handled as a control. So it's not handled through the entire system. It's handled just at the time of analysis. So it's a batch control. How about that? So this is one that we started manufacturing, RTI started manufacturing, that was targeted at 0.08, so right at the statutory cutoff. That's the place where you're most sensitive about the variability. And you can see this comes out just a little bit below. We're very reproducible in it. We've got an open control, a batch control that's targeted at 0.08, different manufacturer. I think that one actually is a Biorad that does that one. And you can see it's a little bit closer to 0.08. So we can see, we don't have enough of the blinds yet. It also just kind of gives you an idea of the difference in the scale of the number of blinds we're running. in comparison to the number of batch controls that we run. But out of this, what we can start to do, we're starting to get enough information out of this that I can now run an ANOVA comparing, we have 2 different instruments that alcohols run through. And I can show statistically there's no significant difference between instruments for any of the concentrations. Really tight, cool. I can show, really importantly, the difference between analysts. Got 8 different analysts on there. The width is, so this is an imbalanced one-way ANOVA. The width of those is the number of particular samples that analyst has run. And then the height of it is that individual analyst's variability. Again, no statistical difference. You can see the F ratio there is 0.68. I mean, there's no statistically significant difference between analysts. In other words, analysts get the same answers, even when they don't know it's the control, across many multiple days, across batches, across lots, across instruments, across all of these things. And you can start to look, we're starting to get enough data to now look across combinations of that. So that's analyst by instrument by automated pipetter, and no significant differences between those. So you can start to now to back out and say with statistical confidence across the system that the system is performing consistently, which I think is just way cool. So then Linda was talking about measurement uncertainty. So yeah, this slippery business of what is the uncertainty of the measurement and what is error rate. Because really at the end of the day, most of the lawyers, the question that's always asked is, okay, how likely is it that you screwed up my client's sample? How do we answer that question when almost everything we run is an unknown sample? Well, my opinion is these blinds give us a hook on actually determining error rate, because I put through known positive, known negative, and see what the system from introduction into the laboratory all the way through reporting and all the places where it can get hosed up in between, what comes out the other end. So we do measurement uncertainty. We have an uncertainty budget. We report an uncertainty of measurement on each of the measurements. So, giving the confidence of that individual measurement. But working with Cliff, and this is where I always wish Cliff is here because I can't explain this stuff very well. It's a power experiment. So the power curve that he's calculated out of this, and Cliff's done these calculations for me. This one he did accommodating our measurement uncertainty estimates. And so out of that, if we look at where we've got a 0.999 power, that gives me an offset of about 0.0026 about. He also calculated it for me just based off of the variance that we see in the blinds themselves. There's a different way of estimating the fundamental variance in it. And that, again, at the 0.999 gives, again, a difference of about 0.0026. So, and I've gone back and forth with Cliff on this many times. How do we explain that to a jury? What would you stick on a report? I'm not ready to stick this on a report yet, and I'm really curious how people react to this. So the thought is now we could say the statistically calculated chance of a true alcohol concentration at or below 0.00774, so really close to that 0.08 statutory cutoff, being reported above the statutory cutoff of 0.08, so the chance of a false positive is less than 0.1%. Based on blinded control data routinely run through HFSC toxicology laboratory under the same conditions. So lawyers, does that answer the question? How likely is it that you screwed my client's sample up or not? I don't know. Do people understand that one? Hey, Bill.
Would you give this in a case where the measured concentration is 0.0774?
Well, yeah, so there's the one that I've kind of scratched my head about it, of just how it's used. It was used as basically at a general comment. Now, we got one quirk in Texas, that Texas's impairment laws are written that you were above 0.08 at the time of the accident, meaning almost every time we have to deal with a retrograde extrapolation, which I hate, but that's the reality of the way the law is written there. So, I can say about the measurement, but all of the overlay of the uncertainty in the retrograde extrapolation is tough to wrap your head around.
Yeah, there's a transposition of conditional issue.
Yeah.
You can provide data on the probability of getting a particular measurement, get the true value of such and such.
Right, and yeah, I've gone back and forth.
What's the probability of the true value of such and such given what you measured, which is a different thing.
Yeah.
Right, so it's a tricky
It's slippery. It's really slippery. How to be statistically correct, yet something that the layperson can understand and internalize, okay, how likely is it that the lab hosed this up? The thing that I think about that's important about this one versus measurement uncertainty is that value being reported. This accounts for all of the potential error from the entry of the sample to the laboratory to reporting, that we haven't transposed something, that we haven't mixed up some part of the reporting, that we haven't gotten the wrong sample, because that's all controlled within the fact that this control does the whole system. So now how we position some of this stuff, I'm still scratching my head on how best to say it, of if this is just a general statement. Obviously, the closer you get to 0.08, the higher the chance is that it's going to go over, and the farther away I get from, so I get down to about 0.07, the chances of my reporting that above a 0.08 is vanishingly small. I mean, it's 10 to the minus 6 or 7. Mark?
Is it possible for you to simply start with the number of 0.08 and then give the confidence interval by saying that it would occur between 0.0774 and between 0.0774 and 0.08
Yeah, the 0.224 on the other side.
Right, less than 1.1%.
I think that might be a way to do it. The other things I've thought about is if you take binomial power distribution, you basically plug in the number of blinds that we have run, you can back out, say, something like a 95% confidence that our chance of a false positive result is less than basically 0.01. The idea on this is trying to give it some relationship to that statutory cutoff. I'm not sure, but I'd be really interested in people's feedback on how that works and the thoughts on what actually reporting error is, because we're actually getting to a point where I've got enough numbers to actually play with.
So rather than pick 0.08, which you can't really form a confidence interval around it if it's not your measurement in the case, wouldn't the normal thing to do, pick your measured value and give your 95% confidence interval around that, but then you have to explain what that means,
Right.
which is a long-run proportion in which we measure values at this level, we will be, you could then say we will be above 0.08 instead of having this arbitrary number of 0.07. But I wouldn't pick 0.08 as if it were.
Well, with
a measured
0.08
value.
comes because of the statutory requirement. That's the cutoff.
No, I understand
Yep.
that. And so it affects what the jury uses it of, but you're not forming a true confidence interval around 0.08. Confidence intervals apply to measured values,
Yeah,
not to statutory limits.
yeah. We got another.
I'm just wondering if maybe you don't have two numbers more than are necessary in that statement. From the jury's perspective, they probably know 08 is the legal cutoff, but if they don't,
Yeah.
it doesn't matter.
Yeah,
All they care about is are you over it or not.
yeah.
Right, so it seems like really the only germane number is the 0.1%. And you could just make a generic statement that you show in every case saying that
Chance of
the
false
chance,
positive is about 0.1%.
even that's too technical, don't confuse them with false positive. But yeah, the chance that what I'm reporting to you is above the legal limit when it shouldn't be is whatever you've calculated for this particular case. And that way there's only one number, and that number is the risk.
Bill's scowling over there.
I think we have what David Fegman calls a G2I issue, right? So the difficulty of going from the false positive rate shown by general studies and what's the probability the analyst erred in this case
Right.
is not, it's a tricky issue,
Yeah.
and it's a logical mistake to assume that you can get to one from
Yep.
the other without taking into account the other evidence in the case. And there's a real danger that the jury is going to think, if they get a number like
Right.
0.1%, that's the probability that the analyst is wrong in this case.
Right.
Even though there may be other evidence that's either incriminating or exculpatory that they should be
Yeah.
combining with it. So it's a tricky problem, one that requires, I think, more thought than we've given it. So
And it is a real tricky one that honestly, particularly now in alcohols, I think we're getting to a place where the most significant source of error for us in a lot of these things isn't within the lab, it's at the collection and handling of evidence. So yeah, all you lawyers, never, 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 ever assume that the right evidence has made it to the right place. We see probably 15 to 20% of the cases that come to us have evidence crossed between cases, stuff inverted in cases. I mean, it's a real thing. There was one hand back there. I'm sorry. We need to, Brandon, holler if we need to move on. Obviously, I can.
There are a lot of questions, and so we should take a couple more, but we should.
Well, just, it's a comment asking for your response. And that is, you mentioned both the likelihood, Bill's comment on the general to individual, but also you mentioned the retrograde extrapolation, which is a separate source of error, but and it seems to me that, I mean, that the almost the only right way to get that in front of the trier of fact is to tell them that. We can tell you that as measured, and then that's a hard enough problem as you've just been discussing, but
right.
As measured, here is the level we actually measured. Now to figure out what it was at the time it was collected, there's another calculation, and then you have to talk about that. It seems like the only way the trier of fact can evaluate that is if you tell them those two things.
Oh, yeah. Any other? Oh.
One last one.
While we're waiting for him, the other thing with that is that when you do the retrograde extrapolation, you have to be very clear in what assumptions you're making with the calculation, because there are several.
Yeah, and we do a lot of things on that. We won't do anything unless there's at least a 2-hour window between the cessation of drinking. We basically try to make it as large a window on that as we can.
Just a quick thought about the legal dimension. There is a Supreme Court case dealing with measurement uncertainty associated with IQs for the purpose of intellectual disability determinations in capital cases. And what the court ended up saying, which doesn't make a huge amount of sense actually, was that you had to have a measured IQ above 2 standard deviations, 2 standard errors, in order to declare that below, in order to declare that the true IQ was 75 or above, which was the cutoff that was acceptable under the AAMC standards. So anyway, this is not a unique issue here.
Oh yeah, it's trying to pin down error is a slippery spot.
Just about your open.
Hold on one second.
Just about your open versus blind comparison. You were saying the 2 samples, they were just from different sources, and that's why they were.
They're different
biased,
manufacturers, right?
Different manufacturers. So why didn't you just do with the same manufacturer, open and closed, to compare sort of like apples to apples?
Because there's no way, so that like this one for UTAC, the way it's packaged, the way it's manufactured, I can't get it into a tube. So what we spent a fair bit of time with RTI dealing with how these are manufactured. So alcohols are usually in what's called a gray top 10 mil tube. So when you go to the clinical lab, you know, the Vacutainer tubes that they put on there, that's the kind of tube. It has a gray top on it, which means the preservatives in it are sodium fluoride. Wow, get all kinds of things going there. Sodium fluoride and potassium oxalate. So you can't get it in there so that it looks like a sample. So when RTI manufactures these, they actually take gray top tubes. They've got a jig that actually goes through the cap like you would with a venipuncture sampling, so that the tube really looks like it was taken as a venipuncture. And I can't get the other manufacturers to do that. They're basically manufactured in a different way. And honestly, I want multiple different manufacturers, because we see this all the time in toxicology, that if your calibrator is manufactured from the same source material as the control, you could have a systemic bias that you can't see. Mm-hmm. So you want these things to come from different sources. You may not need to go quite as carried away as 4 different manufacturers that we use, but at least having some of these in different manufacturers helps control for that.
One quick question. You said the Hawthorne effect, you've observed that examiners do behave differently. Have you been able to diagnose whether
Yeah,
it's
most all of
better
it
or
is
worse?
anecdotal. The things, and I've heard this out of a lot of laboratorians who say, well, we can never do blinds because it's too expensive, we're too small. I mean, those are real. But the other is that I would really argue with is my analysts would hate it. They think we're going to spy on them. Actually, what I find is quite the obverse of that. The analysts love this. They think it's great. One, because I kind of made it a game. I think there's some of that, and they get a lot of coffee out of me. But it also gives them a very positive, very objective answer to how do you know that you did this sample by procedure? Because I don't know if I'm handling a control or an actual case sample, and all of the controls that I have handled have all turned out X way. So we publish every quarter, we put a report that goes out on the website of the blind performance. Their names are associated with how many cases, how many blinds they did, what the performance was on those. I'll say, knock on wood, out of the about 400 we've run, everything has worked as we would expect it to so far. And like I say, I can kill a whole nother day on some of the stuff we've done in latents and firearms in particular. But they really like the fact that they can answer that question that way. All right, get me out of here. Thank you all.
This is great, thank you.
Okay, great. So I'm the non-lab or section director who's snuck on to this panel, so thanks for having me. I'm also presenting data from Peter's lab, so I feel like I'm a fraud in a way. I'll also try to move quickly through this. I'm cognizant of our time and want to make sure that Henry has time to speak as well. So these data come from a collaboration between UVA and the Houston Forensic Science Center that we're really, really fortunate for. Alicia in particular at HFSC has been kind of our point person on this, so many thanks to her for helping us collect these data that I'll talk about. So these are very, unlike some of the presentations we've seen earlier, including Peter's, these are very, very basic descriptive data. Not a lot of inference really can be made from them because we're not sure kind of in isolation what they mean. They're going to mean something once we have something to compare it to. From subsequent data collection at Houston, from data collection at other labs that kind of looks like this. But we think this does provide a helpful kind of baseline for comparison and provides an illustration of self-study that's replicable at basically any lab. So the data that we have are from 2 years, so 2014 to 2016, came from about 2,500 cases, and you can see kind of the range of offenses reflected across these cases, a lot of burglary and robbery offenses, all the way to capital murder. We can do things like this, compare kind of the cases coming into the latent print section at Houston to overall Texas UCR data and see kind of how those patterns might shift and change over time. So reflected in these about 2,500 cases were over 12,000 latent prints. But when we look at that kind of initial threshold decision about whether a print is even of value for a subsequent comparison, that number drops off dramatically to about 5,000 prints, right? So less than half, or 44%, are kind of deemed of value for comparison. And when we look at what those prints are, they're not just fingerprints, although almost 2/3 or 3/4 are. They also have palm prints, joint impressions, and other impressions reflected in there. A really wide range in the number of prints that might be submitted in any particular case. I think we all kind of feel really bad for the person with the 153 print case. But the mode there is one, right? So just a tremendous amount of diversity, but also kind of reflected in the fact that often there is just a single print submitted. Of those prints that are deemed of value for comparison, when we look at kind of what the conclusions drawn from the comparison are, about 60% are identifications followed by exclusions, and then the remainder are inconclusive. We were really curious about the verification process, so the process when a second examiner looks back at the case. At the time we collected these data, or the time period reflected in these data, these were not blind verifications, so the second examiner was privy to some of the first examiner's conclusions. And we also know that not all cases were verified at that time, so about half of cases were not verified. About a third of cases received full verification, meaning that every decision made in the case, from that threshold decision about whether the print was of value for a subsequent comparison all the way to the end. And then about 8% of cases had only identification decisions verified. We were able to look at all of the different analysts in the fingerprint section in Houston to see how often they got assigned to one another as verifiers, right? And ideally, over time, you would hope to kind of see normal distributions across everybody in the division, right? So analyst A would be assigned or would have cases assigned to analysts B through L kind of an equal number of times. And so that was, in this sample for these dates, truer for some analysts than others, as you can see. So when we looked at the cases that did get verified, and specifically the consultation and conflict resolution processes that followed, so these were instances when the two examiners who were verifying the print did not agree on the outcome. Consultation is kind of the first step of the process, and if the examiners don't agree there, it proceeds to conflict resolution. So only 3% of all cases proceeded to consultation, right? So only in 3% of all cases was there any examiner disagreement. And this was only 7% of all cases that had been verified. So essentially, we can draw from this that during verification in this time period at Houston, analysts agree 93% of the time, which is a really high kind of inter-rater reliability rate. We're so curious to see if that rate changes or stays the same perhaps when blind verification gets introduced, and we can look at that data. When we look at consultation, so again, these instances when two examiners disagree, and pretty rare instances at that, we only had 82 cases and 132 prints kind of in this subsample. And interestingly, here's kind of the one trend that we did find. Final decisions were those of the verifier as opposed to the original analyst, about 3/4 of the time. That was true regardless of seniority. So we were really curious to see if seniority had a big role to play here, maybe if people deferred to people who were senior to them in the division. That's really not the case, right? So the verifier seems to be prevailing here, kind of regardless of who is senior. The original analyst decisions was slightly more likely to remain if the verifier was junior, but again, not a really significant effect here. We were curious about kind of what the post-consultation decisions were, and they ranged across the board. So these are just the value, no value decisions, and you can see that, again, the verifier's decisions, those top two rows are what's prevailing here. So there's a change during consultation, but about equivalent numbers of the time is a latent of no value changed to a latent of value, and then a latent of value changed to a latent of no value. So there's kind of no significant trend there other than the conclusion is being changed when it does go through the consultation process. When we look at the kind of evaluative decisions of identification, inconclusive, and exclusion, most of them seem to center around the kind of threshold between identification and an inconclusive, and an exclusion and an inconclusive. So about kind of what that, the boundary between, or what the parameters of an inconclusive decision are. Our kind of modal outcome here was an exclusion was changed to an identification. Following that, an exclusion was changed to an inconclusive. But again, these numbers are so small and they reflect such a small kind of subset of the overall data here that we can't really draw inferences from them. But descriptively, we kind of thought that this process was interesting. Again, just because so often it did reflect a change in the consultation process. Conflict resolution, so that kind of ultimate stage, if you know, even in the consultation process, folks don't agree. These were only 8 cases or 10 prints total. So this is a very, very, very small subset of the data. Here it was about 50-50 in terms of the case analyst versus the verifier. And again, no real significant trends here. They're kind of across the board in terms of what's happening in the conflict resolution process and whether things are being changed. We're psychologists by training, so we're always curious about individual differences. So we had a range here, no absolute novices. So in terms of years of experience, we had a range of 6 to 28. In terms of the percentage of their caseload that got verified, this varied from about 1/3 to 2/3 of a caseload. Consultations ranged from about 1 to 22% of a caseload. We did see some differences in the percentage of cases that proceeded to consultation. So somebody on the high end had about 95% of their cases that were verified proceed to consultation. Folks on the low end had about, I think, 10 to 20% of their cases proceed to consultation. We were so curious kind of about what was driving kind of the 95% rate for examiner A there. And even though we're the psychologists, the Houston folks were quick to say, I think this could be a personality variable kind of at play, that some people are kind of more, I don't know, stubborn in their decisions, and some people are kind of easier to work with, more willing to take somebody else's perspective and see another outcome in the case, and so that personality may be driving some of these findings as well. Conflict resolution, as you can see, was just so small that the mode was to have 0 cases proceed to conflict resolution. So again, we can't really make many inferences from these data, but they are relevant for comparison, both to other labs and post-intervention at Houston, for instance, after blind verification gets implemented. More, I think, about verification procedures and looking at processes where we know analysts have the potential to disagree, and helping to understand exactly what the sources of disagreement are, or what might be predictive in terms of predicting disagreement that might help us kind of help people arrange caseloads, things like that. Individual differences are, of course, of interest, and I think from our standpoint, in particular, an emphasis on the processes that result in these individual differences, and intersection with things like print quality and human factors research. So it may be that the person who has that 95% consultation rate is kind of getting the cases with the lowest print quality, right? Just objectively harder cases. And our kind of end here is that more data are needed, right? Both from Houston and from other labs, again, to provide that basis for comparison. All right. That was quick, right? All right.
Thank you.
Well, good afternoon. My name is Henry Swofford. I'm the chief of the Latent Print Branch at the U.S. Army Criminal Investigation Laboratory, which is a subordinate unit of the Defense Forensic Science Center. And the distinction is we operate in austere environments overseas to support the warfighter, and we also support the criminal investigative mission for the Department of Defense. So if you've seen the show in NCIS, we support NCIS agents, OSI agents with the Air Force, and also CID agents with the Army. Most importantly, according to our attorneys, would say that this is my own personal views and opinions. It is not necessarily official or reflective of the views and opinions for the Department of Defense, Department of the Army, or any other affiliated entity of the federal government. Speaking near kind of 2/3 of the way through, I think it's clear to you that over the last several years, the forensic science community has faced intensifying criticism and scrutiny. And this has led to a series of calls for reforms. Not just once, not just twice, not even 3 times, but 4 times. Now, I'm slightly hearing impaired, but I think I've gotten the message now. And I think it's starting to resonate with the rest of the forensic science community as well. Now, although these recommendations and calls for reform have come from a variety of different scientific committees representing a variety of different scientific organizations, there's one thing that I would say transcends each one of these reports, and it's this issue that the forensic practitioner serves as the center of the entire process. And this is highlighted with Sharon's last presentation, the fact that the outcome of a conclusion or the outcome of a case can vary, and the subject that we might even attribute that because of different personalities, that should be a cause for concern. And so I would highlight, or I would summarize, the current state of many of our pattern evidence domains with this one slide, and I've done this in a variety of different presentations, so some of you might have already seen this. But the issue is that the human analyst serves as the instrument of detection of the feature attributes within the evidence. Now, in and of itself, that's not so bad. We might want to move towards objective automated detection systems, but in the current state of what we've got, that's not so bad. The problem starts arising when the same individual then moves on to serve as the instrument of measurement. And the complication is that we don't actually take any measurements. We don't take any physical measurements. And then I, as the analyst, then take it a step further, and I evaluate the significance of the measurements that I never took against criteria that doesn't exist to substantiate a conclusion. And then I march into the courtrooms, and I ask the judiciary, the fact finders and the judges, to believe me ipse dixit. So I might dress in a neutral manner. I might get a haircut that day. I might look the audience in the eyes or the jury in the eyes and help them relate to me. These are actual aspects of our courtroom training. And so from a scientist, I struggle with this issue. What I believe, which I believe is similar to the recommendations put forth by the various general scientific community, is that we need to begin moving in this, to operate in this model. A model where it's okay if the human analyst serves as an integral component of the feature detection, but then we need to incorporate other means to measure the physical attributes of the features that we're utilizing. We need to actually take those measurements such that I can point to those measurements, such that I can hand-harry those measurements. And then we need to take those measurements and evaluate the significance of them against measurements taken from ground truth data sets that I can point to, data sets that I can show you, data sets that I can show the legal fact finder, so they too can visually see the significance of the observations made. Over the last several years, we've begun an effort with considerable help from several people in this room as well, notably Alice Liu, Karen Kafadar, and the C-SAFE team in general, along with other statisticians from NIST, Hari and Steve Lund and so forth. We have made an effort to take a first step towards developing a solution. This is not the solution, this is a solution. The idea is that we take a fingerprint, and where most laboratories will stop and they say, I believe these two prints may share a common source. I believe they match. We'll take it a step further. We too believe that, but then we'll take it a step further and we'll measure the similarity, and we'll summarize the similarity of the configuration of features within those two impressions. And then we'll evaluate the significance of that similarity statistic, as we refer to it, against ground truth data sets that have been modeled with these probability distribution curves, such that we can evaluate, is this similarity statistic measured from this particular case at hand more in line with the similarity statistic values we would expect to see from impressions of which we know came from common sources or from different sources. In March 9th, 2017, we launched this within the the military criminal justice system. And so since then, we've been reporting out the actual quantitative results of our fingerprint examinations. This is a snippet of an information paper that we issued throughout our trial counsel, defense counsel, and investigators around the military system, and have been reporting in this manner ever since. We've had one case as of February that now the cases are starting to go to court that we began reporting last year. We've had one case go to court for which the analyst testified to these results in the legal system. Now, as I mentioned a little bit, the concept of how this is applied, this does we've considered this as an extension of the existing methodology for analyzing fingerprint examination. Again, where most laboratories will say, I believe these two impressions share a common source. You see some blue annotations there. That's our cheap manner of annotating the feature details for encoding it for the system. The analyst here has indicated that I believe these 15 features between the two impressions are in sufficient correspondence, but we don't really know if they truly are insufficient or not. Once they encode it, they'll launch it in through the system, and the system will measure the similarity. This value indicated by the blue is the similarity statistic value or similarity score. That's just simply a unitless value that summarizes similarity between the two configuration of features. In this particular case, it came out to be a value of 54. Now, the similarity score in and of itself is essentially meaningless. You have to evaluate what's the significance of this score in relation to measurements taken from ground truth data sets. The next value the software will calculate is, based on our ground truth or empirically derived data sets, it asks, well, what's the probability of observing this similarity statistic value or lower among the data set of prints we know came from common sources? Or in other words, for this particular case at hand, what's the proportion of similarity scores originating from common sources, same source impressions, is lower or less similar than what we've observed for this case at hand? In this situation, it happens to be right in the middle, so it's about, it's 0.49 or about half. The next question is, well, what is the probability of observing this level of similarity or more extreme on the higher end among impressions we know came from different sources? Or in other words, what's the proportion of impressions we might expect to observe among impressions coming from different sources that has a higher degree of similarity than what we've observed for this case at hand? And here, the empirical data is actually that we observe 0, but we don't want to claim 0, so we have made some assumptions and we have estimated what we might expect that to be. In this situation, we expect that proportion to be approximately 0.00005. Then we put those two numbers together, which is not a likelihood ratio, but we still chose to make a sandwich of probabilities. And we find that it's 96, the probability of observing this similarity statistic value or lower among mated source samples compared to is about 96,000 times greater compared to observing this similarity statistic value or greater among non-mated samples. So that's the snippet of how this software works and how the results are interpreted. What you'll see on our reports is the latent print on Exhibit 1 and the standards bearing the name Swofford have corresponding rich detail. The probability of observing this amount of correspondence is approximately 96,000 times greater when impressions are made by the same source rather than different sources. And then we include this technical note that goes on and writes a little bit of a book there. But the one thing that I want to point out is that one, we disclose the software we utilized, and two, we've decided to toggle between how different people may interpret statistical evidence. So some people may look at the 96,000 and say, I understand completely what that means, and that's enough information for me to make a decision. But we've also known that not everyone has that luxury to interpret in that particular manner. So what we've decided about 2 weeks after we launched this software is we also include a statement that provides the context of the probability ratio in a binary match-non-match framework. So according to our policies, we say that you will not report a conclusion out unless you have a probability ratio of 10 or greater. And so that's what we indicate here, and we classify that as just an association between two impressions. Now the question is, where did that come from? Well, that came from our developmental validation, where we found that the specificity rate, where you consider the probability ratio in essence like another score, we found that having a threshold of 10 or greater has a specificity, observed specificity of approximately 99%. And of course, as you increase that threshold, the specificity also increases at the cost of your sensitivity. Now, the software results provide, as I mentioned before, the probabilities of a similarity statistic value are more extreme when prints are made by the same source versus different sources. It does not give you that the answer to the $1 million question. Is this person the source of the print or not? It does not provide the probability that a specific individual is the source of a print, nor does it provide the probability of observing a specific configuration of features in the population. Now, moving forward, we have developed this system, again, with some extremely valuable input from a variety of different individuals within the academia community. And we have decided to make this freely available for any government-based U.S., federal, state, or local laboratory. Absolutely no charge whatsoever. They may use it, they may evaluate it, they may do whatever they choose to do with it. The only condition is for hopefully a limited time, we can only transfer the software and the underlying materials to them via non-disclosure agreement. And the reason for that is because we're actively trying to find a way to license this to a commercial entity such that we can ensure long-term sustainability, support, and hopefully improvements to the underlying technology itself. Now, it's really easy to stand in front of all of you and say, why do we not have change? We've developed these tools, why do we not have change? And so I want to end with a couple of slides on the challenges that we are facing to promote change, and it boils down to a cultural change, a cultural issue. And I highlighted this a little bit during the lunch session of, we have got to have a commitment from all stakeholders of the criminal justice system if we truly want to move towards reformed practices. So the question is, we've made this software available, and there have been several researchers that have made even more sophisticated software capabilities available for the community to use. Yet, we have progressed very slowly in practice. So there is a disconnect between the research industry and the practice industry. So how do we bridge that gap? How do we get from point A to move away from this concept where the human analyst serves all major roles in the examination method? And how do we integrate statistical concepts and statistical methods into a crime laboratory setting? Now, this is really where the disclaimer kicks in. This is my own personal views and opinions. Over the last few years of our journey, I would say there's 3 big salient issues that we need to concern ourselves with. And that if we don't address these issues and we continue to focus on improved technology, we're going to always fall short of implementing them into practice. In no particular order, one thing that we are lacking in the forensic practitioner community is a fundamental knowledge of probability and statistics. We don't understand. We've never had to understand. We've never had that background education. And so we don't understand. And more complicated is you're asking forensic practitioners to testify, although to many of us sitting in this room, very basic statistical concepts, to them it is like rocket science. And so we have to find a way to bridge that gap, for which I'm extraordinarily pleased that CSAFE and others are moving towards incorporating and providing some sort of basic statistical training for the practitioner community, because we will move nowhere until we start bridging that gap. The other thing we're facing is a legacy culture. And I would describe our culture, or I should say, I believe our culture is best described as that we are operating in a investigatorial culture. We are not operating in a scientific culture in many crime laboratories across the country. We've heard from some notable speakers and from the Virginia crime lab system, the Houston crime lab system, who are moving towards a scientific culture, which is notable. Unfortunately, this is a very small proportion, in my opinion, of the 411 crime laboratories that we have operating in the United States today. We are operating in an investigatorial culture. I would stop short of saying we're operating in a prosecutorial culture. However, I will say that senior leadership of many laboratories do ask the question, how often do we get a positive result that has led to the conviction of an individual? I'll leave that inference to you whether we're operating in a prosecutorial culture. I'll stop by saying we're operating in an investigatorial culture. And doing so creates some conflicts when we try to integrate a scientific culture. And then, last but not least, again in no particular order, one of the challenges we are facing is a lacking leadership emphasis to integrate quantitative and statistic and probabilistic concepts into the laboratory. And so I put that up there hopefully to make a grounded yet slightly provocative call to my colleagues in the leadership positions within forensic crime laboratories that if you truly are interested in moving the community towards these efforts, that you've got to have a demonstrated commitment to do so, more than just simply saying it at these conferences. So the strategy, and again, I cannot stress the caveat, this is my own personal views here. A plausible strategy for us to consider is, number one, it's got to start with leadership in a crime laboratory. The leadership has got to do more than simply say they're committed to this. They have to take some actual steps towards commitment. I've heard from too many leaders in the forensic science community that says, we're just not ready. The practitioner community doesn't want it. I think we need to, the culture has got to start from the top, and we've got to make a demonstrated commitment to reform. And then we have to stop asking whether a new method will achieve legal admissibility before we ask the question of whether it's scientifically valid. That demonstrates that we are valuing legal admissibility over scientific validity. I assure my colleagues in the forensic science community that if you focus on scientific validity, it will necessarily follow that you will achieve legal admissibility. But if you focus on legal admissibility, you may achieve that in some circumstances, but that does not necessarily mean that you will also achieve scientific validity. So we need to commit to reform and value the tenets of scientific validity over legal admissibility. And then, which I've already mentioned, CSAFE has started this effort, but others need to come on board and be receptive to establishing foundational requirements and educational requirements that require the next generation of forensic scientists to have some background in probability and statistics so that we lessen the learning curve. And then promote statistical thinking and logic. And last but not least, this ties into demonstrating a commitment to reform. Begin to implement probabilistic reporting schemes in the various forensic science disciplines. Move away from reporting to court this succinct, great manner, but makes a claim that you cannot scientifically defend. So I leave you with those Henry thoughts, and I appreciate your time.
That was wonderful. We should start our next panel soon, but maybe take a few questions first. This poor Peter got all the questions so far. Oh, yes, yeah, Bill.
So, Henry, are the latent print examiners in your lab, are they limited to presenting the FR stats results, or can they also give their own opinion on source events?
Is this on?
Yes.
Okay. The way that I've handled it is that I realized that I chose to take the Band-Aid of the culture off quickly. And so I restricted our analysts from making claims of identification, which carry implications of same source. And I also restricted them from a policy standpoint that they shall not make a claim that two impressions were made by the same individual. What I've also made it clear is that ultimately they can do what they want to do and they're going to do what they want to do. And so what I said is, I will provide you the tools, I will provide you the appropriate framework that you can operate in, that you can testify to, that you can put on your reports. But if you go beyond that, and further, I'll even give you the tools to provide some quantitative basis to it. But if you go beyond that, then you need to caveat it, that's your personal opinion, that you cannot necessarily defend this scientifically. And at the end of the day, if you go on record and someone makes an allegation that your opinion exceeded the limits of what can be supported scientifically, that was your choice to do so, and I will not have your back. I will have your back all day long, provided you stay within the realm of what we can support and defend from a scientific standpoint. I understand there may be different views of how other people may manage that, but that's how I did so. And what I found is that they wanted to make it clear to me that I knew that they could ultimately do whatever they wanted. But then when we've been faced with those situations, not one of them have actually gone beyond that and said the two prints came from the same source. They've used the terminology and the analogies I've given them, and we found it's been quite effective.
Yes, Harry?
You listed 5 points in your last slide. I have some concern about the last point.
Okay.
You seem to suggest that probabilistic conclusions or testimony is somehow scientific.
You make a very good point, and I should clarify that the last bullet was operating in a probabilistic framework. Whether we have the quantities, hopefully we move towards those quantities, but moving away from this notion that just because two evidence samples match, therefore they came from the same source. What I want the practitioner community to be able to do is to explicitly and publicly acknowledge there is a chance for error. Even when they did everything appropriately, acknowledge there's a chance for error. So I use the word probability in a very generic fashion, but you make very good point there.
More questions? We have lots of questions. Yes.
I just wanted to point out similarities with other communities. You, among others, have suggested rather strongly that we're facing a cultural problem. I happen to agree with that. Many people here may be familiar with what's currently called the reproducibility crisis. There are various scientific papers concluding this are not reproducible. And it turns out that one of the primary reasons for that is because the underlying experimental methodology was never sound in the first place. And what I observed from an academy meeting last week is that when this particular point is brought home to practitioners in the field, there's enormous resistance. It's just the same as what we see here. It's a broader phenomenon than just in our field.
More questions? You had a question? Oh, yeah, David.
You indicated that at this point, you're having examiners give ratios like 9500. And they're not giving the components of those. They're not making the statement you made, are they? This goes back to Harry's observation about empirical facts. You've got your distributions. You've never seen this high a similarity score from non-native pairs. And you're using a model and relying on it to come up with a very small number, 10 to the minus 6, which is going to have itself a lot of uncertainty in Harry's lattice. So would it be better, is what I'm asking, to say a little more and say, by the way, we about half the time see this under one condition, and almost never see, well, we've never seen it yet in another condition. Would that tell us, would that be a more accurate statement of our knowledge than producing a full throttle number of 9, 5, 4, 3, etc.?
There's different ways of doing it. Whether it's more effective or least effective is something that I think is yet to be studied, and I would entertain that. But yeah, I mean, ultimately, there were certain decisions we made and for a variety of reasons in how we've reported, but I make no claim that it is superior to any other method for which we could report the numbers. We could separate the numbers, we can include them at a ratio, we can base it on the empirical data, and so forth. So I would encourage the community to bring those ideas of what they believe would be more effective or different strategies for reporting it, and we can evaluate which might be optimal. We made a choice that to go with one method to get something down and move forward with it, but we can always alter course if we find the studies supported a different way of going about it.
Last question.
So you are talking about more effective, but the focus perhaps is what you really know. More effective implies there is some result you are anticipating. So maybe we should think about what do we know? Are we stating what we know currently?
And that boils down to modeling the empirical data and just simply saying, here's the results in relation to the empirical data versus here's what we modeled from the empirical data and made some estimates for. Is that what you're referring to?
I'm not against modeling. I'm just saying that if you choose to model, there's extra baggage you have to deal with.
Sure, sure. I believe there was one more question if it's still interested. Oh, okay.
Sure.
I just wasn't sure where you got the .00005. Is that right?
That was an estimated proportion based on the model, based on the different source distribution for which we modeled our empirical data from different sources.
But not from any actual instances of dissimilarity.
Correct. We never observed a similarity that high from different source impressions, so we made some assumptions and modeled what that we might expect that to be in the distribution.
There's no level of similarity, like really high quality prints with 18 points. If you have your analyst go and testify to a match.
Could you say that again?
There's no point at which you have your analyst testify to a match.
Well, in circumstances for, correct, until we, correct,
I just wanted to clarify.
yeah.
Okay. Even if it gets to the point of 18 points, really fine prints, you always have the FR stat language, and that's what they're expected to testify to.
Right now, the FR stat is limited to 5 to 15 features, and that's just a limitation of the software. As I mentioned, this is one very baby step or no step from a technology standpoint, but a step forward from a cultural standpoint, and that's where much of my emphasis is from. If we can get some statistical method that the forensic community is willing to embrace, this is going to create a demand and then hopefully an influx from commercial providers that can really do more sophisticated capabilities and strengthen these numbers.
Okay, well, one last question, but we should, it's your own panel, so, you know.
Just a clarification, when you say different source,
Yeah.
where are these different sources being generated from? And are they ever generated from APHIS so that it would actually be a challenge because APHIS would produce very similar, and so it would give you a comparison group that'd be a little bit, I think, more interesting.
The different source distributions are based on limited to the delta region of fingerprints, which of all of the different regions of available in a fingerprint, the delta region has been demonstrated to have the higher chances of a coincidental match under no constraints of rotation and translation. So you take n number of features and find the optimal match among m number of features available to the limited to the delta region. If you take close non-matches out of an APHIS system, you will find more similar prints. For the different source distributions, we've just taken prints, paired them together under how I just described, not APHIS close non-matches. In our development paper, it's quite lengthy, but we include a subsample where we actually did take close non-matches so we can demonstrate how the specificity rates will vary. In the development of this, we found very different opinions as we sought assistance from the statistical community regarding whether the different source distribution should represent close non-matches or should represent prints just paired together at random. And so what you're seeing there is prints paired together at random, but limited to the delta region. We do have a sample of much smaller sample of close non-matches, however, that we disclose how the error rates may be expected to change.
How different is it? Is the distribution similar? Is it
We
dramatically
took
different?
delta and core regions of APHIS close non-matches, and the core region of APHIS close non-match had similar distribution compared to the delta region of randomly paired, but the delta region of close non-match, I would say was considerably more similar. I can't recall specifically how much.
Interesting. Well, thank you all so much. Why don't we just take a 5-minute gap between panels? And hopefully we'll have just as many or more questions at our last panel. Thank you all.